Okay, so for the top-down assembly, we're going to sketch this profile, the rectangle for the gasket. Rectangle, we'll put one of these as a solid, one of these as with the through hole. So we have 100 millimeters on the diameter, 60 millimeters on the interior, 3 millimeters. 8 holes there. Not sure where they got 16 holes there, but we're going to stay with the 8. The M8 by 1.25 by 30, 13 millimeters thick. All right, so we'll just go through that geometry. And we're going to approach this in a couple of ways. So I'm going to do the new assembly millimeter. And if I do an assembly sketch, so we're just going to close this. If I do an assembly sketch, this is pretty much going to be the same technique for the multi-body or the master model, depending on terminology, but same basic technique. And let's go with, we'll start with the sketch entities, even though I tend towards the S key now. So infinite length, vertical, attach it to the origin, select, L on the keyboard. Would kind of like that to be the radial, but we'll go ahead and use some of that numeric input. 65. And oops, I got out of sequence. So we'll just keep going at the relations as needed. Close that off. And then we are 60 on the interior and 20 on the bottom. And then I do want to see what I can do with making that radial. All right, so number 50. I was looking for it, pick it up there. Since I don't see it, I'm just going to go over to the leaders. Oh, it picked up the line geometry. So what we're seeing is the difference between the linear versus picking the object and the center line and having it set to 100. And then we should get, let's say I'm looking for the min-max radial. Nope, there it is, radial and diametral. All right, so somehow those keep moving on me. All right, so line for the gasket, and then we'll stop a little bit short and complete the rectangle. All right, so we have a height of 3 millimeters for the gasket, a height of 13 millimeters for the lid, and then the minor diameter of the M24 will be 24 minus 3, so 21 millimeters. And then we go ahead and accept. All right, so a second sketch that I might be interested in doing, and I could do this on each part individually or tie the parts together, but if we tie the parts together, then we're going to be anything that changes in that part is going to affect the other parts downstream. All right, so I'm about to violate one of the very first rule of top-down assembly. Assembly 2 is not what I want to name this. So I did a practice piece and went all the way through, and it tied. So at the end I will look at doing the correction, but we want to see what's going to happen here. So top-down pressure cylinder as our name, and if we don't save this first, we have some corrections to do. So let's do this as the revolve envelope, and then on the top plane I can do a sketch, and we'll just go with the S key. Let's see, we're going to go back into our sketch, pick the circular pattern, and it's looking for the center, and did not find the center. Interesting. Okay, so 8 entities to pattern. Guess I didn't pre-select that. Okay, so it found the point once I selected the entity. The radius will be the 75 divided by 2, so 37.5. Let's go ahead and equal spacing, dimension the radius. And that's going to move a little bit, so we need to relate that geometry back to the center, and we'll make the line vertical. That'll get our sketch fully defined. So now we have hole positions, and we have the side profile. So this could be the bolt. Oh, did not want to do that. All right, so I thought I had single clicked and single clicked. Bolt circle. And I'm going to go ahead and hide those. And when we first started this, we had the option to create a layout. So if I go to the layout, I can do the same thing, except this is going to be a 3D sketch. So if you want to try the 3D sketch, then go ahead and give this a shot. But if you don't, then just kind of watch the process, and we'll pick up with the 2D sketch here in a little bit. So vertical. And I still want that to be construction geometry, so I'm just going to sketch this in. So basically reproducing what we did, except I'm in a 3D sketch this time. So we'll add those geometries and then put in those dimensions. Okay, so the 100, 60, 20, 65. And when it reverses, that's always interesting. So let's go ahead and drag those up a little bit. And apparently that one did not get coincident. So 3, 13, and then we said we were going to be 21 for the whole location. All right, so advantage of the 3D sketch, and this geometry is fairly simple, but if I wanted to, instead of opening up that second sketch, I can double click on the top plane, and we're going to go with a bolt circle of the 75 diameter. So let's go back into the sketch, pick up the point, and then we need to see if the okay, so make vertical. And I'm going to go ahead and put in that dimension just to make sure that it doesn't move, because the 3D sketches, things move unexpectedly. So 37.5. And that doesn't look like it lined up, so like I said, unexpectedly. And it's weird it's not pulling that up. So let's go with align, and it's vertical. We'll put it for construction. It found the endpoint, so I can put in the dimension. Not sure what I picked. That still moves though, so okay, well, always interesting to see what the 3D sketch can come. All right, so we don't have a linear sketch pattern, but we do have the first position. All right, so that would give me enough to at least have that relation. And if I really wanted, I could draw those points in. But we are going to move on. So let's go ahead and save just one more time. For our component then, instead of inserting components, we're going to do a new part. And it asked me for a plane, but I don't always want it to be on the front plane. So let's go ahead and rename this top down, pressure cylinder, body, base, something along those lines. And we have the brackets that shows that this is an internal component to the assembly. It won't exist outside of the assembly. So I'm going to edit that part. It turns blue. Now I'm editing in the context of the assembly, so I'm going to sketch on the front plane out of that component. And then we're either going to trace over the top or convert entities. So if I trace, I go into the L on the keyboard, and we can click, click, or click, drag. And if I go to convert, we're just going to select, control, select, control, select, control, select, and back into the sketch and convert entities. And so if I want to convert the center line, it's going to come in as an object, and then I can take that object line and make it construction. So if we go features, revolve boss base, 180 degrees, then we rotate over. I want to do the S key, go to the hole wizard, pick the tap. It's an ANSI metric, and we'll scroll down to the N24x3, and this is going to be an up to next, and we'll set the position at the center. All right, so if you're using the 2D sketches for this, it's going to work pretty much the same way. You're picking up the geometries, and they should be identical. All right, so for the top, let's go ahead into the hole wizard, and then looking down at the side, I encountered this before, so I knew to look for it again, but the first time I didn't catch it. We are in inches for our document units, our default part documents. So M24x3, we need to change to M8x1.25. And instead of up to next, it'll be a blind in condition. And you want to make sure that when you put this in, we're going to do 17 millimeters. And what ends up happening a lot of times on the manufacturing side is if we do this math, we're 30 millimeters long, which will be pretty close. It's somewhere between 29 and 30 on the length of the screw. It's going through 13 and 3, which is the 16, and another 17 would be 31. So a millimeter of clearance, not real great. So the 17 millimeters would be the thread depth, and then the hole depth needs to go deeper so that the tap can complete the cut to at least 17 millimeters. So in that case, it becomes a min thread condition. So I would look at making that 25 and give it a nice generous clearance rather than something that's going to end up too tight. All right, so if we go into the sketch and circular pattern this time, we can generate 8. Has the radius. We're going to do the equal spacing. I'm going to go ahead and turn off the dimension radius since it was kind of already there, and I want to see, and since these will go through, that means that when I typed in the 17 and the 25, I was not paying attention and did not put in the millimeter. Okay, so back to the positions. If I grab one of these and move it, all right, so I'm not seeing the center, and since I didn't let it dimension, then this would be a good place to put in a bolt circle. So I draw a circle. I like to make it for construction, and then we'll drag one of these off and away, and then come back and go coincident to the circle. The others didn't come in, so usually we have to add 2 if we go this route, and then everything goes fully defined. All right, so that gets our geometry. We edit the in context, exit the in context, go ahead and rebuild. And then from the front plane, and I want to make sure to edit, not the in context. So if I go to the front plane and open up a sketch, it should warn me. Maybe I turned that off. I probably turned it off. Anyway, there should be a warning that says you're editing the assembly sketch, not in context of a part. All right, so back to the assembly, insert component, new part. We don't want to have it pick the front plane for us, so just click. And this is going to be the gasket. And then when I right click, edit the part, that will put me to where I can select the front plane. We go into the rectangle, and I saw that grab the midpoint. At least I want to double check. Yeah, it went coincident. Did not, doesn't look like it grabbed the midpoint. So again, we will convert. Let's stay with the sketch convert, because I don't remember if that's on the S key sketch. And then we can revolve features, revolve boss base, and OK. All right, so to start this one out, we will go with the whole wizard. We are still in inch, pounds, and seconds, so I did not change that. And we want this to be a clearance hole. Oh, we need to make that selection. So we're going to do the straight hole. And then in the type, we can do screw clearances for an M8. And we'll go up to next. And then the position comes down to, well, if we hide that, let's go with the hidden lines visible. And then back into the sketch, I'll pick up my points. And as I drag across those edges, the centers will highlight, and I can tie this to the other part. The danger here is that since I did not tie this to the 2D sketch or the layout, that if this part changes, then I'm affecting the gasket as well. All right, most of the time it's not going to be an issue. You just have to be aware of it if it generates that error. So that creates the gasket. And then we can go, let's do the S key, insert components, pull down, new part, click to clear the plane selection. And then we'll do the lid. All right, and then we can edit that part. And we need the rectangle, so I guess it would help to open up the sketch. So front plane, sketch, S key, rectangle, go from point to point. And then we can go to the features, revolve boss base, the axis of revolution. I didn't particularly like that. Right, so it's not. It wants a local sketch center line. So we'll convert it, do the object. I could always go into the line, make it construction line, center line, infinite length vertical, and attach it to the origin. Or I can convert the one that's there. Since we're doing all of these conversions, I can also use the existing. All right, so when the lid completes, then that's fine. So I'm going to switch out of the layout, since well, we can do that as a circular pattern. No, I'll stay in this one, and then we'll look at it from a sketch-driven pattern as an alternative. All right, so in the clearance hole again, screw clearance is M8 up to next position. Then we'll go ahead and accept. All right, so that puts in the first item. And on the features, I want to do a circular pattern. So this is going to be a feature pattern as opposed to a sketch pattern. And the feature is the clearance hole, so that was selected. And I'm either going to pick the center, or I'm going to turn on the temporary axes, but looks like it will also let me pick the line. So I go with the cylinder geometry. We want a total of 8, and then to accept. All right, so that's one option. And I'm going to, we can reuse the M8. So let's just press out the circular pattern. I'm going to right click, and my layouts, hide layout and suppress layout. So I do want to hide the layout. And we will show the bolt circle. And for this one, the M8, and in the features, go to a sketch-driven pattern. And the selection then is going to be on the bolt circle. So everywhere there's a point in that sketch, it's going to apply the geometry. So again, this is a try it. If it works, if you built it out with those geometries, then the circular pattern and the sketch pattern both have advantages. The advantage here of the sketch pattern, though, is if I had a large pattern, and both of these over a sketch pattern, I'm sorry, the in-sketch circular pattern versus the feature patterns, that if there were a lot of holes, so when I do tooling plates with hundreds of holes, I pretty much want it to duplicate those features, not have to calculate it out of the sketch every time. All right, and then the last is going to be to insert the annotation for the cosmetic thread. And it picked up the metric, the machine thread M24, up to next. And no, I don't want it to show the type when it does the insert. So accept that. We go to the save. And then are we going to save internally inside the assembly, or save externally? Externally makes the 3 separate parts with those names. For now, I'm going to save it internally. We might want to do something different. Assignment doesn't entail the drawings, so we will do the drawings as an example after. All right, so I can hide to clean that out. And then the last is to add our M8 by 1.25. So the toolbox is not added, it isn't loaded. So we pick the ANSI metric, bolts and screws. This is going to be probably a hex head, formed hex screw. I have to look at the standards, but let's see if we. A lot of times I just pick one and see what it generates. No matching size, so we can just escape out of that. We'll go back into the design library. Heavy hex, oh, those were heavy. So formed. Okay, so got to pay attention to the description. No matching size, but there is the M8. And to pick the length, there is 40. Well, that's not going to work. All right, so it needs to be in the library. And then a hex cap screw. No matching size, an M8, but at least it's a little shorter. And 30 millimeters, and we generate the geometry. So with this, I can go ahead and put at each location, and wherever I click, it's going to put one, or I could do this circular component pattern and have those go through. So let's just click. And the main difference is if I miss, I'm going to have to add that mate. So in that case, we'll go ahead and put those in as a coincident. Oh, 7. All right. So to make the option, let's go ahead and suppress that group out. And for our assembly, and under linear component, we'll have circular component. The axis, again, will be either a temporary axis or something cylindrical. We want equal spacing, 8 pieces, and that does the same thing. The main thing is we end up with a folder of the local circular pattern, and I can hide, suppress, do all of those as a group, whereas these we have to select, or what I usually end up doing is if I'm at a top level, I will add to a new folder, and then this will become the hardware. The last thing we really need to do here is create our exploded view. And we pick our components. So I'm going to do the auto spacing, and we'll see what that looks like. So we need all the components. Could pick the features out of the tree if we needed to, but that gives us our items. Find my arrow, and the base will stay the same. And I don't think I picked a direction, so let's get rid of the direction, but then I lost my orbit. Okay, so let's click through, pick a new reference. All right, so the Z face. Okay, so the Z face, the arrow. Well, let's just go with 100 millimeters and see if that kicks it out. Okay, I can't say that I've had it do that before, so let's kind of back out of it and start over. Auto space is on. Let's just go ahead and grab the hardware. Okay, we got those. Got that. And then there's the orbit, so I'm not sure where I lost that, but we did. And would have thought that those guys would have come up first. Interesting. So let's see what we get on our spacing. Okay, that definitely reversed it. There we go. So we go through the components. Maybe drop that back down to 70. see what it looks like in an isometric view before I let it go. Okay, so that was strange. I haven't picked the auto spacing that way before, so we'll go ahead and save it. We can always do them individually if the auto spacing doesn't cooperate, and go through the process that way.